this is just links for some basic libraries. First, there are some links for Python basics. Then there are links for NumPy. Then there are links for Pandas library. Then there's link for Regex. So Regex is basically used for pattern matching, and it's used across languages as well. So for finding patterns in a specific database or specific column, this is used. Other than this, there is matplotlib and cmon. So I had posted this link in the Doubt group. So I'll be creating a blog out of it, and I'll be posting it along with the recordings after the sessions today. So if you're not part of Doubt group, then that's also okay. So what for today's session, what we'll do, I saw these links and I have taken one link out of it, specifically this one. So this is a very comprehensive link. Okay, it has a different table of contents, different data structures, what are the different commands related to data structures, and then tuples, sets, dictionary. So these ones we have already covered in previous sessions. We'll try to look at the different commands that are used with them. All right, and then there is also NumPy and Pandas. So we'll try to cover as much we can. Whatever we have already covered, we will try to skip it. All right, so let's get started. So let me just give a heading here. So whatever will get remaining here, we'll try to cover it in the next session. Let me quickly import the dependencies. So we might need NumPy, we might need Pandas. So whatever example are used in this particular notebook, we'll just try to take our own list. We'll try to create our own list, and we'll try to see if we are able to replicate the whatever concept has been covered here. All right. So before we move forward, let me just quickly create a list. So a list you can just create with square brackets. It can have multiple data types. So these are some concepts which have already been covered. So now there are two things. One is tab and shift tab. So if I just press tab, it'll just give me properties of a particular object. So whether append or clear or extend, these are the properties of this particular list, right? So if I just append something to it, let's say 5, and then I print A again, then I'll see that 5 has been printed at last here. Now similarly, as append is there, if I just click on shift plus tab, it'll give me the definition around it, or basically its properties. I mean, what append does, right? So for that, I just need to press shift tab, and tab is used for looking at different properties. Okay, so let me just quickly mention it here. Import properties, and then shift plus tab. Details about it. Okay, cool. Now this is just a markdown. I just created this cell and I just clicked on M. On the top also, if you will look in your, I have basically hidden it in my environment, but if you look on top, you will have an option of cell or markdown in Jupyter Notebook, or in general in any other Python environment as well. So if you'll just keep it just like this, if you'll just run through this cell, it will look something like this. Now to avoid it, you can either make it into a heading like this. It will, with the help of hashtags. If I'll give more number of hashtags, then it will become smaller in size. Otherwise, it will be bigger in size. Or you can give it kind of a numbering. So whatever the number, and then followed by dot. So it will look like this. Or else you can give normal hyphen like this. And if you just run this, it will basically create into a bullet points. So this way you can kind of make your Python notebook more interactive and for someone else to easily understand it. Now, one more thing which a lot of folks had reached out to me for was that there is module not found error. So whenever you are trying to download or when you're trying to practice on a data science project or any Python project, let's say, if you are just copy pasting something from internet, right, you might be able to come across some modules which are not already installed in your Python environment or Anaconda. So there are two ways of doing it. One way is that you can go to your terminal, right? You can go to your terminal and or say command prompt or Anaconda prompt, and you can just open and you can just type here pip install. And let's say if I have to install any particular library, let's say I would install Cbond, right? So why will I go and install it? Because if I'll be running it here, just as import Cbond, let's say for SSNS. So for me, I have already installed it, so it will run. But in some cases, there might be a module error, which will be basically module not found error. When a particular module is not installed, then you particularly get that error. All right. So one way of doing it is I'll just click on pip install Cbond, and once I do this, it should ideally tell me that it is already installed. So you can see here the requirements already satisfied, right? So this is one way, but other way is that you can just open a cell here, and here itself you can put an exclamation mark and you can give the same command. Right now, if I just run it here quickly, it'll also do the same thing. It'll be faster as well. Okay, so there'll be a difference of seconds, but let's say if you're trying to install a heavy library, then you'll be able to see that it becomes much faster. All right, so these are just a couple of things which I wanted to cover before getting started. And, yeah, one more thing. So this is an output, right? So there are okay, I think there's a question. What is the difference between conda install and pip install? So pip install is basically by Python you are doing it. Okay, so you will do it in your own this system or your own command prompt or terminal. Okay, but if you're doing it in if you're doing it in conda manager, right, similarly as command prompt or your default systems command prompt or Mac terminal, you also have Anaconda prompt which comes with Anaconda. So if you will do in that, you'll probably have to write conda install. uh, that's how it works. So Anaconda is nothing but a wrapper on Python itself. Now pip is specifically used for Python, and since Anaconda is built upon pip itself, you just use conda. So like basically there is no difference between them. They both will do the same thing. It's just that they're used across different terminals or tools. Okay. Yeah, one more thing is that you see a output here, a lot of output here. If you just want to hide it for some time, you can just press O. So it'll just, again, if I'll click O, then it will again show the output. So I'll just give a comment here. Okay. Now let's say if this output is there, or let's say this particular output is there for A, and there is like a lot of output, and I want to basically can you like, I think someone is not on mute. Can you please go on mute? Yeah, thanks. Okay, so there is an output here. Let's say there is a lot of output and your entire screen is filled with the particular output and you're not able to move up or down, right? So in that case, what to do? You can just press R, and then now, what did you see? It basically became from a coding cell to basically a raw NB convert cell. Okay, and now I'll press Y again. So now it has again become a normal cell, a coding cell. So you just first change into a, so this is kind of a shortcut. You first change it into a raw cell and then you again convert it into a coding cell. So I'll just press R and Y. I'll just write R and then Y to convert a coding cell or to basically clear the output. Okay. So if you just want to hide the output, if you want to look at it later, then it will be better if you will just hide the output. But if you want to, run it again completely, then it will be better to just clear the output by just pressing R and Y. So I just ran it. Now I'll press R, then Y. It went away. It got cleared. All right. Okay. So I'll just give the reference here. So for this Kaggle notebook, so that you can go through it. I'll put the PDF of this, so you can just copy paste whatever particular code you want to copy paste, and then you can just run along. All right. Okay, so we'll just get started with this. Okay. Other than that, the basic Jupyter shortcuts you all might be knowing that if I just want to add a cell above this particular cell, then I'll just press A. I'll keep pressing A. If I want to add some cells below it, I'll just press B. So like this, I can just keep adding, and I can just select all of them, and I can press D for Delhi. I can just press it twice. Similarly here, I can just press it twice. Now this particular cell also I can delete. If I just want to get it back again, I just try to press Z for zebra. So it'll just come back again, right? Okay, so let's get started with this. Now here there's the table of content, data structures, and this one, and in 1.1 there is list comprehensions, adding conditionals, examples. So let's jump right into the lists. So lists is uh, they are used a lot. You can also look for output here. You can hide the output. So from here it has basically started. These things we know about list, they are mutable, so we can append something to it, we can delete something out of it. There is the concept of mutability. Then are they ordered? So ordered is about order of element in an object. So you can basically use indexes in list, right? So let me go back here, and the list that we had created A, if I want to look at the indexes of it, I can just look from 0 till 3. So 1, 2, and 3. Only 0th index, first and second index have come here. This gets neglected, the later index, basically the stop index here. So you just get the values of 1, 2, and 3 here, right? Okay, so this for ordered. Now, in a brief way, they have just tell here that it can have a mix of data types, ordered and mutable as well. Let's look at list comprehensions, all right? So they have just created a list here, and they are using capitalized names. So let's try to break this particular code, and let's try to understand what is happening here, right? So now this is an entire code I have put here. If I just want to break this cell, okay, if I just want to split the cell, so let me just write the shortcut for that. Other than that, let me also write the shortcuts for adding cell above, that is A, then adding cell below, that is B, then deleting a cell, that is DD, and then undo a delete, that is just Z. Okay, cool. Now for splitting a cell, we use shift plus like this. So let me just write it in this way: control plus this. Okay. So yeah, you just have to press this. You can actually look at these shortcuts here as well, and yeah, here as well. You can just look at it here. These are different shortcuts. Just by just going to help and just looking at them. All right. Cool. So let me just close it. Okay, now let's try to see what is happening here one by one. This is, we can change the names to something else. Let's say we can put the name of planets or something. So let's put it as Earth. And okay, cool. Now let me just split the cell here so that I can one by one see what is happening here. So I printed this, and this is names. This is how it looks like. I can probably look at its fourth index. So it'll be Uranus. If we'll try to access the fifth index, it'll give me some error that the list index is out of range, because there are 0, 1, 2, 3 only until 4 index, right? Now here what is happening, he's defining a empty list. An empty list is getting defined. Then there is a simple for loop for name in names. For name in names. Names is your list. Now this for name, this you can keep it as I also, or let's say J also, or whatever you want to keep it. All right. So for I names, capitalize names dot append name dot title. Okay. So let's first try to see. So this part is easy. In this capitalized names list, they're just trying to append something. But what is this doing? Okay, let's try to understand what this is doing. So let's paste it here, and it's saying name dot title is not found. Okay, now this name was basically what was defined here as name. So let me just make it I. Okay, so for I, now what, when you try to type for I in names, let's try to see what exactly it does. So let me just print it, print I. Okay, so it'll just print all of these individually, right? So let me do this. If I just want to see Mars, what can I do? I can just do names 0. It'll give me Mars, right? Now if I'll try to do this for I in names, print I, instead of it, let me print I dot title. Okay, so it is just printing again the same thing. Okay, we can actually look at it in this way. I'll first print this, then I'll print this. So it's actually printing the same thing. So let me split this cell here, and let me just run this particular part. So it got ran, and now this capitalized names, it was a blank list, but now if I try to look at it, it will look like this. So it is nothing but exactly the same list only, the same list, whatever we have here. But further, they are doing some operations. So so what they're trying to tell here is this: you can either put a for loop, or you can put the loop in this same format. Okay, capitalize names equal to name dot title, or in our case this is I dot title, and this also we have a name like this. This also gives the same result. Okay, so there are two ways of doing it. Either you put a normal for loop, or you just do whatever operation you want to do for I in names, and that you give inside a new list. Okay, let's say if I, instead of this, I just make it upper. So if I run it, you can see that it has become capital, all of them. Or if I just want to make it lower, so then all of them have become lower. So like this, you can do it. Cool, let's move forward. Then adding conditionals, do for if. Okay, so let's see what is happening here. Let's give a heading here of this particular one. Okay, I'll just put in a heading format. Okay, so let's try to see what is happening here. First, they're defining squares. Now, squares is x to the power. This is used for power basically. For x in range 9, if x divided by 2 is equal to 0. Okay, so first let's try to see what range 9 does. So let's do like this. For I in range 9, print I. So it basically gives you everything from 0 till just the last, whatever the number is given here. So till 0 till 8, it will print out everything. Now let's try to see what this specific one does. So if x divided by 2 is equal to 0, basically these are the values of x. If we will divide them by 2, so let's try to see this. 7% is 2, it gives you 1, and 7, just a minute. Yeah, ideally it should be done. Okay, basically the percentage gives you the remainder, right? So if whenever you're dividing it by 2, if it is giving you equal to 0, in that case only you will have to basically square it. Okay, so now let's try to run this particular part. Let me just split the cell here. So it got ran and then I just print it. So we have 0, then we have 2, 4, 6, and then 8. All of these numbers, if we'll divide by 2, it will give us 0, right? Like as we are seeing it here. So similarly, if I just take 3, it's giving a reminder of 1. So this particular criteria is not getting satisfied here. So whenever this is happening, it should just give us a square. So for these ones, it is giving me a square of this. Now, the next condition is to add else statements, move the conditionals to the beginning. Okay. So this same condition is this: if it is greater than 0, then I should do this, else x plus 3 for x. So this particular part remains same for x in range 9. This particular part from here to here, it remains same. But this particular part basically changes. So now if I'll try to print it, for all the odd digit numbers, it will give me a square. Otherwise, for the even digit numbers, it will give me a square. For odd digit numbers, it will just add 3 to it. Okay, now if I just run it and if I just try to print it out, 0, then here was 1, so 1 plus 3, 4. This became a square, then here it was 3, 3 plus 3, 6. Similarly, if I look at here, 5 plus 3, 8, and 5 plus 5, 10, right? Okay, let's move forward from here. Then, yeah, here if we'll try to look at it, it is just trying to split the first names here. So, let me just take this part. So, okay, so first it is just defining a list, and after that it is trying to get the first name out of it. Okay, so for getting the first name, it's easy if we'll try to look at it in a string format. So let's say if there is this single string, okay, this is a single string, and if to this string I just do a split, we'll just split it into two different strings. Okay, inside the split, if I give a space, then whatever space is coming in between them, that will get removed basically. Okay, now here what it wants is, after splitting it, it just wants the 0th element. Okay, so here let's put 0. So it'll just give me the first element. Okay, so for each of these elements, for name in names, it just this new list will just have the first names of each of these names. Let's look at this. Similarly for here, for I in range 1 to 21. So let's try to see what happens here if I'll just try to print this one. This is I in range 21. I'll just print it. So this range will start from 1, and similar to as indexes we give, right? A colon B. Similarly, like here 1 till 20 it will go. The 21th will not get printed. So here if I look at multiples 3, what it is doing is for this particular range it is just multiplying it. So this is kind of straightforward based upon what we have just covered, right? So let me just break it. Now what is this? This is a dictionary, keys and their corresponding values. They want to basically figure out which of them passed. Okay, they want to create a list out of it, which of them passed. So it's a simple condition, name for name, comma score in score.items. If score is greater than equal to 65. Okay, so what exactly is happening here? This particular thing is the name, and this particular thing is score. Okay, this one. And from this list, how can we look at it is, okay, let me just first run it. Now if I just try to look at it, then this is scores, sorry, scores dot keys. Keys will give me the dictionary keys, right? So we have these many keys, and then similarly I can get the values, or I can look at the items. So if I look at item, it gives each of these items, right? And for each of these items, I just want the name. I don't want the score. Okay, so name for name comma score in scores.items. This is name comma score. So this is how it is reading it. Okay, and it just wants whenever the score is greater than equal to 65. So this value is greater than 65 for this one, and this last one. So these three are just getting printed here. You're first saving them in a list and then you're just printing it out. All right. Cool. Cool. So moving forward, let's try to look at the Lambda function. Now, what the Lambda function does is it's nothing but a normal function, but it's in an anonymous format. So anonymous in the sense that if I just have to write a small function here, which, or let me just give a heading here first. Okay, this, yeah. This is just the basic structure of a function. I'm just defining a hello function. So this function does nothing but it just takes an argument, let's say name, and then it just prints that name. So it prints hi plus name. Okay, this function got defined. I can just call this function and I can use it multiple times in my entire code. Okay, and here I can just give the name as Mr. Arun. So I'll give hi Mr. Arun. All right. Now let's try to see what Lambda function does. So the Lambda function, as you can see, you just have to give the argument Lambda. The way we are giving def here for defining the function, similarly we are giving an argument Lambda here. And these are just two arguments that we're giving, and this is what we want it to do. It can be anything. It can be x to the power of y, or it can be x percentage y, right? This is just an equivalent of this. So this is a different function. Like this you're calling it, and in a similar way you're calling it like this. Okay, you can just name it x as well. So, or let's say z. If I just print it like this, so inside this z I'll just have to give 3, 4, and okay, let me just make it multiplication. will just give me 3 into 4, 12. Here they have used 4, 7. So here it's not as straightforward, but let's say if you are doing it for pandas data frame, right? So instead of defining a separate function, you can there itself kind of create a particular function inside the particular column itself. Like here they're trying to do it, right? Apply lambda function to a list. Okay, I think there's a question. When do we use map function? Okay, yeah, map function, here it will come. So I just put it. In the end, there is something that is coming here. Okay, so yeah, here they are just applying the map function to apply a lambda function to a list. So this is the list that they have defined. So let's first try to look at this list. Okay, so this is a list, and it has multiple lists inside it. Okay, each of the element is in itself is a list. So if I try to print the 0th index element, it will come out to be the first one, like this. Now, one way of doing it is this. If I want to calculate mean of it, so I want the sum of so I just defined a kind of x. I can just make it x also. Let me just make it x. This function, what it will do, it will do a sum, and it will just define it as a length. So I do this, and then this map then I can use on this one. So what it does, let's say, so see this particular part list, this is just used for creating a particular whatever output is there into a list format. Okay, what it is doing here is this map function, it takes an argument, the first argument, it can be anything, it can be sum also. Okay, it can be sum, or it can be any kind of, let's say, float also. Okay, and then whatever operation is here, whatever function is here, or whatever method is here, that it will apply on this particular object. Now this particular object can be a list, dictionary, set, tuple, anything. Okay, for our case it is mean, and what mean is doing here, it is just taking the sum of everything here, and then just the length of it. So yeah, so if I just run this one, and I just run this, and if I'll try to look at averages, then for each of these items, it is giving me a kind of a mean for each of these, right? So this is what I've done here. Whatever function that I had defined, I just applied it to on this numbers. Okay, or you can just put the entire thing into in one part itself. So instead of this mean, they have just taken this entire part, right? So the good practice is to do in small parts and check if it is running or not. If it is running properly, then just combine them. So combining is kind of easy in Python, so you can just combine them. So I just combined it, and then I'm just printing it, so you'll get the same output exactly. So this is what map function does. You can also press on shift plus tab to look at the doc string. Okay, this is not giving the doc string for it. Okay, let me just separately put it. Yeah, so here if you can see, it makes, so if you look at this doc string, right, it is the function, and this is the iterables. Now iterables are nothing but your data structures only, let's say, or a list or a tuple, where each of the item you can iterate over, or you can basically repeat over. Make an iterator that computes the function using arguments from each of the iterables. Okay, arguments means each of these arguments from each of the iterables. It stops when the shortest iterable is exhausted. Basically, when this ends, it stops. All right, cool. Okay. So let's look at the next one. So there is this filter, and filter is used for basically filtering. So let's look at this. And okay, let me just paste this one first, and let me come back and paste this one. Okay, what is happening here is